All right, for Tuesday's lecture, I want to start by showing what I mean on the things that we have to know, the things we're going to kind of need memorized. And so, what we're going to find is we're going to find the things we need to know about derivatives. We'll have the definition of the derivative, which is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. And we also have an alternative form where f prime of x is equal to the limit as z approaches x of f of z minus f of x over z minus x. And we note that h is equal to z minus x. And so these are the two definitions that we might turn to. Now from these, we're starting to develop some rules. And the first rule is if I use the notation that I'm taking the derivative d dx of some constant c. Well, if we graph a constant function, we see that it has a slope of 0, and the derivative is related to slope. We have the idea that if u and v are functions of x, then the derivative of the sum of two functions of x is equal to the derivative of the sums. If we play around with it a little bit, we'll see that we can make the sum and the difference be the same. And we have a constant multiple, and the derivative of some constant times a function of x, so we'll say u as a function of x, then that constant multiple times the derivative of the function. When we worked out what the derivative would be of a product of two functions, and we found that it's the first times the derivative of the second plus the second times the derivative of the first. Make sure that's a v and that's a u. Right, so the first times the derivative of the second plus the second times the derivative of the first. We found our quotient rule. If we have two functions u over v, then in the derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. If we take a derivative of some function to a power, then we bring the power out front and reduce the power by 1. And these are our derivative rules that we have had so far. What else did we explore? We said, hey, if we see that if we define the limit specifically to be some number, then the function where that limit number equals 1 when the function is 0 is e of x. And so we get the derivative of e of x is equal to e of x. And we also saw that was related to the derivative of any base to a power is equal to that same base to the power and the natural log of the base. And these are all the rules we know right now, and we should work on memorizing these. A really, really good idea is do what I did here. Start with a blank piece of paper and write down what we remember. I kind of talked my way through these. This is the one I actually remember the most, and these I see as relationships to that when we were building polynomials. These we had to prove. And this, we did a little hand wavingness, and we found this. And in the process of finding this, we understood this. And we'll look at that in more detail as we move on. But there are a lot of, you use the derivative rules a lot, and so we want to try to have these memorized. So just starting with a blank page like I did there. Let me get the book out, and I want to stop the video, and we will start with section 3, 4.